A great developer experience starts with a project setup, and we have found 5 ways to drastically increase the developer experience. And in this video, I'm going to show you these 5. And before we do, I want to quickly talk about the developer experience from the project manager or product owner standpoint or business owner standpoint. Because developer experience, of course, is the experience for the developers so that they have a good start, they have an easy time getting hold of the software. But in our senses, from our perspective, it is about cutting down the cost of development, because as the developers get onboarded faster, that's where the business actually saves time and money. Why is that exactly? There are a couple of ways how that comes. It starts with writing the code. The developer is faster if they start writing the code faster. Of course, you can debate that. It also depends on the quality of the code. But in principle, the less time the developer spends setting up the code, the faster he can actually start a code. They can actually start a code, the faster and the more time we save. The second one is the time for running tests. I get to that later in the video. It's actually interesting how procrastination can be avoided with a good dev experience. And the next thing is the time for getting a code review done. As a good developer experience also comes with a couple of other perks that makes code reviews faster. And then we also talk about new versions and also Q&A, quality assurance. That's all better with better developer experience. I want to give you one quick win in the end of the video, which is the time for QA. This comes in the end of the video. If you cannot wait, jump over, else let's get started. Before I go to the topic, I'm making this YouTube channel. I'm making 100 of those smaller topics. And if you like this kind of content, subscribe, because there are many more to come. Okay, let's start with the boring topic. The first thing, which actually probably not many people like to work on, but it's very important, is a strong README. The README is the first thing that a developer will see. So for example, if you go anywhere in GitHub, this is the README. So basically what happens is when you have a code on GitLab or GitHub, you will see that the README always gets displayed right in the repository. So it's the first thing that people see, and it's the first thing that anyone will read before they actually clone the repository. So this is important. Why do we need to write one? The idea is that a good README gets the developer write the first code fast, meaning they have a good instruction set, what they need to do in order to execute the code locally. That comes over to installing dependencies, any kind of data migrations that they need to run in order to get started, any kind of authorization they need to go through, any kind of requirements that they need to get from the PO, from the PM, in order to authenticate into systems, in order to actually run the system locally. A good example structure, something that worked for us, and you can probably find your own structure, just as an example, is this one. And these are only the headlines. I'm gonna show you a small snippet in the next slide. But basically, this is the structure that we have, and it works quite well for our means. Important is that we cover all the topics of linting. We get to that later as well, how to run tests, how to run local development, how a developer can actually run the tests, and some basic things about the actual architecture. There are other approaches, but in this case, it's a small repository that we use here. The database model is actually quite small, so we include it in the README. And then it continues over deployment. We're also going to talk about this later in the developer experience, and also a couple of miscellaneous things. The pro tip here is that the README can also tell a story. And that's something I haven't seen a lot, and I actually like to do this. It goes a bit into the direction of Jeff Bezos doing his memos. Okay, I found an example of a memo of Amazon. It is written in a narrative form. One sequence of action that captivates the reader so they can actually follow along and understand the topic. And if the README is written in a similar way, it's actually quite beneficial. I did this here in an example, which I show you in the next slide. So for example, what you could do is just list down why the project was started, for example. What's the reason this repository exists? What other repositories are actually using this? If that's some kind of tool that someone wrote, introduce why this tool was written. And also include some things like, how is this even challenging? What is interesting about this repository? What is the first code someone could read in order to get hooked and continue to understand what this is about? So one example that we did in our project here of AnyAdmin, we just basically wrote, this was back then, which I wrote around over a year ago, When I made this project, I wrote it for a friend as a quick example that we can make something in 1 week. And now it's still in production, it still works. And basically, I just wrote the story of how I coded this in Christmas. And I would love if more repositories would do this, because I think it gives a good introduction to the actual code. By the way, if you want to try this AnyAdmin.io, send me a request on LinkedIn. Follow me first and then send me a request. I'm going to accept everybody, and then I can set you up with a free account. Right now we have an allocator feature for agencies, we have a calendar feature for bookings of any kind of sport event, and we have a warehouse. Okay, and also if you just want to try it out, just give me a shout. Cool. Now let's go to the hardest part of developer experience, but also probably the most important, continuous integration. That is a topic that is mega important. And if you're already inside a successful software project, or let's say any kind of professional software project, you probably have that set up. If you haven't done that yet, you might learn something here, and I would encourage you to listen to at least this one section, because it's important for any kind of software project. Continuous integration is a principle where a server, usually a server, takes code and integrates it with the other code. So anytime a change is made, the integration is testing if that code actually fits onto the existing code base and can work together. Basically, the CI server builds the code, see if the build works, then runs the test automatically, and also it writes a report. Let's have a real look how this looks. A CI saves time because, for example, tests run for usually a long time if the code base is reasonably large, and if there are quite a few tests written. If there are just a few tests, you can just run them locally. But if it's bigger, the local code base, or the code base in general, takes a long time to execute in any case. If it's locally with like a new MacBook or on the server, it takes some time. You want that time to not be spent on the developer laptop, because once that happens, the machine might be blocked, or the developer has an excuse to go procrastinate. So there's a good comic here by XKCD. Let's have a look. It's very popular, one of the early ones. Basically, it's back then about compile time. When there was a code compiling, the developer couldn't do much, and so they were doing sort writes. That can happen also with a huge test suite. So we don't want to give the developer too much excuse to always run the tests locally. What we usually do is we run the tests, individual tests that for the features we worked on, we run those locally. And then we push to the continuous integration server, and then we see the tests being performed on the server, so the developer doesn't lose time there. And also, usually, if the tests work for the feature, they also work for the whole system, usually. And this is how it looks. We have pipelines. This is our GitLab instance. We have pipelines that run, and then you see the green check marks if everything worked. We're going to go back to those later. And when it fails, there's a red check mark. So you see that there's something that didn't work on the server, and this report is generated and can then be looked at by everybody. So you actually see how much is the code failing, and you can then go and inspect it. It's very convenient. In conclusion, a good CI pipeline saves time locally, and also, much more importantly, it gives security for the developer. So imagine a really bad developer experience is when the developer changes code, and then it takes ages until they can test the code. So for example, on the server, where it just takes a long time to compile the code, to build it, to publish it on some test server, if there is a long time delay between code change and actual results, the developer experience is really bad, and the developer wastes a lot of time. One more thing to the CI, and that's something that I recently figured out, and I think it's a very important thing. Run a lot of front-end tests. Run a lot of tests where the application, if it's mobile app or web app, whatever it is, gets tested like the user would use it. So what we try to do in our projects, we use something that's a Chrome container in a Docker container, and that runs a software called browserless.io. And so this browser, it's like an automated browser instance that would go and click through your application and then write a test report. That is very handy. Okay, the next point, number 3, is linting. And linting is super important so that the developers know what kind of code and in what style they should write the code. If you're familiar with Python, for example, Python has quite a bit of bit of structure, quite a bit of standards that comes along with Python itself. So you, for example, you always use the indentations. There are other programming languages like Java, Ruby, PHP, where you don't have that. In that case, linting is super important. So it's basically a style guide for code, and there are tools that enforce that style. Looking at this, for example, we have the linting for views, and in our case we use a lot of Ruby. There is a linting for views, meaning the linter, the program that checks the style of the code, goes into the views and makes sure that all the HTML tags have a certain arrangement. So this is already a help, and then we have the same for, oh, by the way, you would use this. So when you have linting in views, the code editor, and of course this also works for normal programming code and not just views, the editor will show you what kind of things are going wrong and can give you hints, and it can even automatically fix them. So that is super interesting and super important, saves a lot of time and increases the developer experience. And yeah, something that I also figured out at one point, it is great if you have a linter and all the team agrees on a certain style, but even better is if you just use the industry standard of a certain style. So what we use now is standard Ruby. So it's basically a standard that is not configurable. So we cannot change this thing. And I think this is important, because if you can change it, everybody says, for example here, the developers might say, yeah, but I want the double quotes. And then they change it, and then now you have a new developer coming to your code base, and now they need to learn your specific flavor. In my mind, it's better just to stick to a standard, and this is standard Ruby here. Okay, now let's look over to the releases. So releasing code is something that hopefully in your project gets done automatically. If this is done manually, if a developer needs to log into a server and change files, usually this is a sign of not working professionally, unless it's some super high security application where people really need to click something by hand. But if it's a normal application, a normal process that every kind of professional software development team goes through, you have an automatic deployment system. It is important because we want to find bugs early. So imagine the deployment system is not automated. Then it takes a long time to make a new version. What we want to be able to make new versions every day, or in some cases every hour, or at least every time we want to test something. So if we have fast release cycles, we are able to find bugs fast. We keep the incremental changes small, meaning we make a new version and then we build on top of that version. We are not working many weeks different in parallel and then have to merge everything. This is called the merge hell, and it can happen. Wastes a lot of developer time. And also it increases collaboration. So if the developer can publish something fast for testing for the QA people or for the product owner, it is much nicer. It looks like this. These are the pipelines. I showed them before. And the pipelines in detail look like this. And this now follows a bit the structure of this talk. We have the build process where we just see if we can install the software in the first place. We have the linting process where we make sure that the software follows guidelines. Then we have the tests, that automated tests that actually run the application in the test setting and check all the boxes that the developer defined in the code. And then there's a deploy mechanism where deploy here in this case to staging and the cleanup phase. And in this case, of course, you see the red sign here. The staging failed, and now we can look into why that failed. A pro tip is a notification. So every time we deploy on staging, we get a notification email. That's something I recently employed, and this is a system I'm going to make another video about this, because it is something that took me like 2 hours to install, and now we use it every day, and it's very beneficial. If you want to know how to make those emails, please subscribe to my channel. I'm going to make a video on how to make those with Amazon AWS by yourself in no time. Okay, now it's the final tip and the quickest win for a good developer experience. And this is almost a trivial thing, but I have seen projects where this is not the case. Usually we have the code base, GitLab or GitHub or whatever you use. And then there's our ticketing system where we actually write, or the project planning system where we write the tickets or the stories or the tasks or the spikes or whatever you call them. There should be a parity. So every kind of story that gets defined should include a merge request, because otherwise why would it exist? Should include a merge request that changes the code. And every merge request should relate to a story or to a task, whatever you call this. Because if it doesn't, why is this there? It always needs a reason. Let's look at this real quick. We are using GitLab, and this is one sample merge request. It got merged already, so this is, oh, by the way, and merge request is for GitLab, pull request is for GitHub. It's basically the same thing. This merge request here closes a certain issue. And in our project management system, because we keep it super easy at this project, we just write an issue. You're gonna see this in a bit. So the merge request, let's say a developer makes a code review and they see, okay, this is the reason why this merge request was done. Let's look into what was the requirement. And then they click on the 25 and then they see the story. This is the story 25 and you see what is the requirement. So then the person making the merge, reviewing the code, can then actually see if there is a parity between the code that got written and the requirements on the business side. And in reverse, every story has a link back to the merge request. This is a quick win, and really it only needs, sometimes you need to link it in the systems. Let's say Jira needs a certain connector to GitLab, but usually you just need the habit for the developer to specify the story ID. And then the linking is something that's sometimes automatically or it's manually by placing a link. But just including that story ID or task ID in the merge request is the requirement in order to get this done. So it's a habit that the developers need to follow, but it's an easy habit and it has huge benefits in the long run. Let's have a quick control over what we just discussed. We usually reduce dev time by applying standards that everybody can follow. And those standards are in the code, in the process, and also in the collaboration. If you like this kind of content, subscribe. And if you have a question, just please send me an email and I will be able to make the next content better and improve with your feedback. And in any case, see you in the next video.